video we'll be doing class C dynamic subnetting. So therefore I'll just introduce one thing, which is variable length subnetting mask. So mask table. Okay, so sometimes you find that it is referred as VLSM table. So therefore this table we utilize it for easy subnetting to make our work easier, as this table is almost like a standard one. Okay, it is a standard, I can say it is a standard that can be used for referencing when you're subnetting. So therefore a VLSM table consists of a block size. I talked about this. The CIDR, the number of bits that have already been used, the mask. Okay, I think you can also include the subnets. So therefore you need to understand that each VLSM table depends by the class that you are using. Okay, so if we are using a class B or class A, it will still have these, but the values that you'll be using, they will be different. So the block size, it starts on 1 when you're using a class A, 1, then followed by 2, 4, 8, 16, 32, 64, 128, and 0. So therefore these are, I think I talked about this in the other video. So these are just numbers which guides us the size of the network that we want to, so the way we want to split it. So these are binaries. Yes, these are binary representations. So 0 is the biggest, followed by 128. So therefore if we don't understand what I mean, 0 is the biggest, so 0 is the same as 256. So we don't write 256, but we write it as a 0 as the starting point. Okay, so therefore so 1, remember the IP address, it consists of the 2 bits. So the block size of 1, since this is the last class that we'll be doing with our subnetting, so therefore it's the one which consists the 32 bits. The one which uses the last slash in the bits. So therefore for the second one, so we'll be just reducing these values by 1. So here we have 31, then here we have 30, then here we have 29. Here we have 28. Okay. Here we have 27. Here we have 26. Then here we have 25, and this one we have 24. I think you now understand. If you're able to refer to the other video, the first video for introduction to subnetting, if you're able to understand what was happening, then you get to understand why there was a /24 in our subnetting when we wanted to start subnetting. So that's what it meant. So 0 goes to /25. When we are using a block size of 128, just know that the CIDR we are using is /25. When you're using a block size of 64, just know that the CIDR is /26, just like that. It's easier compared to calculating. This one we can just pick, more like just picking numbers. So the mask here to be 255 dot 255 dot 255 dot 255. The reason why we're putting this 255, all of it, because this one is the one which uses the whole of it, the whole IP address of a class C. is the block size of 1, it uses the whole IP address of it, the whole of it. So therefore, what will happen for the next value, how we know the mask for when you're using a block size of 2. So instead of using those calculations that we are doing, so therefore this one will be, we do this 255, you subtract the block size that is in line with it. So just remember again, in this in a class C IP address, you have three octets for network and 1 octet for host. So therefore, in our subnetting, as I said, our concern will always be the host octet. Okay, so you get the last value here and subtract with the block size, the one that is in line with it. So here we have 255 minus 1, there we have 254. So again, here we have, okay, let me erase this. Here we have 254 minus 2, then we have 252 here, like that. Then 252 minus 4, then we have 248. Then 248 minus 16, we have okay, 254. Okay, we have, is it 224? Okay, let me do the calculation. Go. Okay, so 255 minus 16, which is still the same. Oh, so here we have 240. Yeah, we are subtract 8 minus 248 minus 8, then you have 240 here. Then 240 minus 16, we have 224. Then 224 minus 64, we have 192. So 32 minus 1, so we have 192 minus 64. So we have the 224 minus 32, we have 192. Then 192 minus 64, we have 128. Then 128 minus 128, which gives us a 0. I think you now understand why we had the default mask for class C as a 0 there. So that's how we calculate the numbers. So in terms of knowing the subnets now, it's really simple. So to know the subnet, just flip these numbers, the block size. So you just flip them. Remember I said the 0 is same as 256. So therefore when you are using a block size of 1, we have how many total subnets? 256. Just like that. I think that simplifies things. Okay, okay. It was too much spacing there. Then what's the other value, which is 120? So here we have 128, like that. Okay. Okay, let me I don't want to. Okay, so the next we have 64. We have 32 here. What's going on again? Then here we have 16. Okay, just like that. Then here we have 8. Then here we have 4. Then here we have 2. Then here we have 1. So you now understand. So when you are using a block size of 0, you can only create one subnet, not beyond that. So when you're using a block size of 128, you can only create 2 subnets. When you're using a block size of 64, 4 subnets, 8, 16, 32, 64, 128. When you're using a block size of 1, you have a total number of 256 subnets. I hope that clarifies things. So that was for class C. So when you're using a class C IP address, just know that the maximum number of subnets we can create is 256. So let's now create a scenario given, and we say given an IP 192 okay, 200.67.11.0/24 IT department. They have 23. Can also say maybe okay, administration, they have you can say 50. No, that's too much again. Okay, they have 12. Okay, customers, since they're always a lot, maybe we can say they have 50. In a day they receive 50 customers. Okay, what other one? So okay, let's add another one, the last. Okay, let's say customers 120 in a day, then they have they have 6 cameras. Yeah, so I think I didn't say the difference or the benefits of using dynamic subnet, why you should choose dynamic subnetting over static subnetting. So when you are dealing with a static subnetting, there is always a wastage of IP addresses. Alright, so if you are dealing with a static subnetting, we'll consider this one which has a lot of hosts. Let's say for example the customer has 120 hosts, so it will be 120. Okay, so that will be 128 plus 128, totaling up to 256. So you can only create, when you are dealing with a static subnetting, given this information, you can only create 2 subnets, that's all. So meaning, what about these ones, these other subnets? How are they going to be accommodated in this network? So that's the reason why I will prefer doing it dynamic subnetting, because will give us the privilege to create more subnets and also assign IP addresses or give block sizes in accordance with what the department requires. So therefore, when you're subnetting, start with the highest going to the lowest. So which one is the highest here? So we have customer, which has a lot of hosts. Okay, so therefore we say customer. Okay, let me skip this. So customer has 120 host. Okay, so you have to pick a block size where 120 can go once and leave a remainder list. Okay, so looking at this, yes, in 256, remember 0, I said this 256. Yes, in 256 can go and leave a remainder, but that would be wastage again. So we'll go with 128. At least 120 can go into 128 and leave a remainder. Okay, so therefore we say our block size that we use is we use a block size of 128. So you see the good part of dynamic subnetting, because we'll be just picking these values here, no need of calculations. So the block size of 128. Then the next is we say mask. What mask are we getting? We are getting the one that is in line with the 120, this one here. So we'll get this mask here, just like that. Then now it's the IP range. So how is the IP range going to move? So first of all, we get this IP address to start to use this same give this IP address will be given as its own network address. Then where are we ending? So we say I hope you're still able to remember 3 portions for the network, 1 portion for the host. So therefore we say 128 plus this 0 at the end, then subtract the 1, that will give us 127. Why are we subtracting 1? So when we count from 0 to 127, we have how many numbers? we have 128 numbers. Hope that makes clear. So also have what is called, we can also include our gateway if you want to. This is optional though, this is optional. So our gateway, I think we can just pick the first usable IP address within this range. So remember, this is the network address, then this is the broadcast address. Hope we are still able to remember from the previous video. This is our network address, this is our broadcast address. Network address, the first address in when you're creating a range, then 127 here, this one, which is the broadcast, the last IP in the range that you have created. Okay, so the first usable, since 0 is not usable, it's because it's the network, so therefore we have numbers now. So what we need to understand how these numbers are moving. So we have numbers of usable IP. We have starting from 1 up to 126, because 127 is the broadcast and the 0 is the network address. I hope you understand. Network portion, host portion, network address, identity of the network address, identity of the broadcast address. I hope that makes clear. So our gateway can get the first usable IP address, which is 1. So we have now, we are left with, I can say, okay, remaining IP. Okay, let me just say remaining IP. So we have remaining IP address starting from 2 up to 126. So we can be changing this number at the end here, this one here. We'll be changing it until you reach the last number that you should get is 126. I hope that makes things clear. So therefore we are done subnetting for this one. Oh, we forgot to put the slash. So here we say the slash that we are using is 25. So we just put 25 here. Okay, great. Therefore we'll go to the other subnet. Let me just copy everything here so that I can just make a little bit of changes. So looking at this information, which other department has a lot of hosts? This one, the IT department. So here we say IT. We'll say IT here, it has 23 hosts. 23. Okay. Let me erase this, erase this, erase this, erase this, erase this, erase this. Okay. So in which block size can 123 go and leave a remainder? Okay, so therefore we have 32. It can't go into 16, so we have 32, 64, 128 and 256. So therefore if we pick 64, that will be wastage, because the number that remains to be twice or maybe thrice than 23. So therefore we'll go with 32 for efficiency. Okay, so therefore the slash is 27, so I'll put 27 here. The block size is 32, so I'll put 32 here. What's the mask? The mask is 224, 224. So what the first so as you can see here, we ended in this network after we created this subnet. So we ended on 127. So what's the number after 127? The number is 128. So we just put 128 here. So just it will be just like an increment. So we're creating another range now, which will start from 128. I don't know wherever we end, but we keep in mind, like I said in the other video, we should not exceed 256 no matter what. We should not exceed 256. Okay, so therefore we'll say now 32 plus 128. Okay, let me get the calculator here. So 32 plus 128, we have 160 minus 1, that will be 159. 159. Oh, sorry, not here, but here we have 159. So our gateway will get another first usable IP. So we have created another range that will start from 128 and it should end at 159. So this is now our new network address. this is our new broadcast address. So therefore the first usable is then the IP after the network address. So the number after 128 is 129, like that. So you are done subnetting for this department here. Okay, if you had issues with subnetting, I guess now we are all good and clear. So let me copy this and create another. So we look at this one here. Which other one, which department follows up? We have admin. Okay, so I'll just say, we say admin here. Okay, if you are following along, you can pause the video, do the rest, then continue the video. After I'm done doing, continue the video, then to see whether you get the same result as I'll get here. Okay, so therefore we have a different. Oh, admin has a 12 host. So therefore, remember here. Okay, sorry. So 12, we get back again to the boxes. In which number can 12 go at least once? Okay, it can go once and leave a remainder. A remainder of 1 at least. 1, 2, yes, like that. Or just exactly. No, okay, I will prefer leaving a remainder. Yes, leaving a remainder at least. So therefore, it is 16. So therefore, the block size that we use is 16. So I'll put 16 here. In line with 16, the mask is 240. So here I'll put 240. Here we ended on 159. So this one will start on 160. So we say 16 plus 160. So that is 176. So 176 minus 1, we have 175. 175. Yes, like that. So our first usable IP to be 161. Still same procedure. Again, next, now the last one, the last department, we have what is called the CCTV, which has 6 hosts. So we have CCTV with 6 hosts. Okay, so what do you have here? So which process can 6 go and the remainder? Therefore at least we'll pick 8, and the one which is close to the number that we have, 8. So therefore what's the mask? 248. So there, just remove a zone, put 8 here. So I have 248. Then the block size that we're using is 8. So we ended on 175. So this one will start on 170. So this one will start on 176. So 176 plus 8. So I have 180, 184. 184 minus 1, we have 183. Okay. So our first usable IP address here will be 177. Oh, 177. Great. Then we are done subnetting. Okay, I hope we have gotten these same results. This same result. Okay. Having done that, now we can try to create a topology that will continue. Okay, so let's now get okay, let me end the video on this, just like this, so that in the next video we'll do class B subnetting. Thank you for watching.